Hello student, now we'll start the fourth part of this exercise, that is exercise 2.4. Divide the number 30 into two parts such that their product is maximum. Let the first part is equals to x, second part is equals to 30 minus x. What condition we have given that their product is maximum? Therefore, we'll take their product. Their product is equals to x into 30 minus x. Therefore, f of x is equals to 30x minus x square. Therefore, it's a first derivative, that is f dash of x is equals to 30 minus 2x. And the f double dash of x is equals to minus 2, which is less than 0. It's clear that the f is a maximum at this point, that is which is the f dash of x is equals to 0. 30 minus 2x is equals to 0. Therefore, 2x is equals to 30 and x is equals to 30 upon 2, that's equals to 15. And hence, the two parts are 15 and 15. Therefore, the two parts, that is a 15 and 15, if we make their product, the product is maximum, that is a 225. Now again we'll see this here. Divide the number 30 in the two parts such that their product is maximum. Let first part is equals to x. Now again I will start. Divide the number 30 in the two parts such that their product is maximum. Let the first part is equals to x. Second part is equals to 30 minus x. Their product is x into 30 minus x is equals to f of x is equals to 30x minus x square. F dash of x is equals to 30 minus 2x. F double dash of x is equals to minus 2, which is less than 0. It is clear that f is a maximum at f dash of x is equals to 0. What's it? It's a first derivative, 30 minus 2x is equals to 0. Therefore, 2x is equals to 30. X is equals to 30 upon 2, that is equals to 15. Therefore, the first part of the number is 15 and the second part is 30 minus 15. And the two parts are 15 and 15. Now the next is divide the number 20 into two parts such that sum of their squares is minimum. Let the first part of this number 20 is x and the second part is 20 minus x. By the given condition, sum of their squares, that is equals to x square plus 20 minus x bracket square. Therefore, f of x is equals to x square plus 20 minus x bracket square. Now differentiate this with respect to x. F dash of x is equals to 2x plus 2 into 20 minus x and the derivative of 20 minus x, which is minus 1. Therefore, f dash of x is equals to 2x minus 2 in bracket 20 minus x. That is a 2x minus 40 plus 2x. Now plus 2x and plus 2x, that's the 4x minus 40. Now differentiate this with respect to x. F double dash of x is equals to that is equals to 4, and which is the positive greater than 0, and this is the condition for the minimum. The given function is a minimum. F dash of x is equals to 0. Now we'll find out the values of x. F dash of x is equals to 4x minus 40, and that is equals to 0. Therefore 4x is equals to 40, x is equals to 40 upon 4, and that is equals to 10. X is equals to 10. The two parts, therefore the two parts are 10 and 10, because the sum of that number is a 20 and the first part is 10, and therefore the second part is also 10. Now let's see this again here. Divide the number 20 into two parts such that sum of their squares is minimum. Let the first part is equals to x, second part is equals to 20 minus x. Sum of their squares is equals to x square plus 20 minus x bracket square. And that's why f of x is equals to x square plus 20 minus x bracket square. Now differentiate this with respect to x. The derivative of x square is a 2x, and 20 minus x bracket square is a 2 into 20 minus x. Into derivative of 20 minus x is a minus 1. That's a composite function. We simplify this. It is a 4x minus 40. Now differentiate this again with respect to x. F double dash of x is equals to 4, which is the positive. Given function is minimum. F dash of x is equals to 4x minus 40, that is equals to 0. 4x is equals to 40, therefore x is equals to 40 upon 4, that is equals to 10. Therefore the two parts are 10 and 10. Now the next example is problem number 12. A wire of the length of 36 cm is bent in the form of a rectangle. Find its dimensions if the area of the rectangle is maximum. Let the length of the rectangle is equals to x centimeter. Breadth of rectangle is equals to y centimeter. Now due to some inconvenience, now again I will start. A wire of the length of 36 meters is bent in the form of a rectangle. Find its dimensions if the area of the rectangle is maximum. Let the length of rectangle is equals to x centimeter and the breadth of rectangle is equals to y centimeter. Therefore the perimeter is equals to 2 in bracket x plus y. Therefore 2 in bracket x plus y is equals to 36. Therefore x plus y is equals to 18, and that's why y is equals to 18 minus x. Now area of the rectangle, that is equals to length into breadth. Therefore this is the x into y. These are the length of the and breadth of the rectangle. Therefore x, and what is the value of the y, is 18 minus x, and their product f of x is equals to 18x minus x square. Now this is the f of x which is equals to 18x minus x square. Differentiate with respect to x. F dash of x is equals to 18 minus 2x, and therefore second derivative of f double dash of x is equals to minus 2, and f double dash of x is equals to minus 2, which is less than 0. Therefore the given function is a maximum. F dash of x is equals to, now we'll find out the values. F dash of x, that is always we make its a first derivative equals to 0. To find out the values of x, 18 minus 2x is equals to 0. Therefore 18 minus 2x is equals to 0. 2x is equals to 18. X is equals to 9. And therefore the length is equals to breadth is equals to x is equals to y is equals to 9 meters. And these are the length and breadth. Now again we'll see here. A wire of length 36 meters is bent in the form of a rectangle. Find its dimensions. If area of the rectangle is maximum, let the length of rectangle is equals to x centimeter. Breadth of rectangle is equals to y centimeter. Perimeter is equals to 2 in bracket x plus y, that is equals to 36. Therefore x plus y is equals to 18 and y is equals to 18 minus x. Now what is the condition that we have given? Area of rectangle is equals to x into y, that is x into 18 minus x, that is equals to 18x minus x square. Therefore f of x is equals to 18x minus x square, and this is the first one. Now differentiate with respect to x. F dash of x is equals to 18 minus 2x. This is the second one. Now differentiate these again with respect to x. F double dash of x is equals to minus 2. Now f double dash of x is equals to minus 2, which is less than 0, and this is the condition for maximum condition. Therefore f dash of x is equals to 18 minus 2x is equals to 0. Therefore 2x is equals to 18 and x is equals to 18 upon 2, that is equals to 9. Length is equals to breadth, that is x is equals to y, that is equals to 9 centimeter. Now we'll see again the problem number 13. A ball is thrown in the air. Its a height at any time t is given by, that is h is equals to 3 plus 14t minus 5t square. Find the maximum height it can reach. Now when this is h is given, that is we want to find out the condition for the maximum. Therefore the value of the h must be the maximum. That is again we will find out the its a first derivative equal to 0, second derivative, and we will substitute the values of the t in the second derivative and we get the required answer. Now h is equals to 3 plus 14t minus 5t square. Differentiate with respect to x. dh upon dt is equals to derivative of 3, 0, 14 into 1 minus 10t. Next is a v is equals to, that is a dh upon dt 14 minus 10t. When it reaches the highest point, v is equals to 0. dh upon dt is equals to 0. 14 minus 10t is equals to 0. Therefore 10t is equals to 14. Therefore t is equals to 14 upon 10, that is equals to 1.4. When t is equals to 1.4, then we will have its a value, that is h is equals to, which is 3 plus 14t minus 5t square. Substitute the value of t, which is the 1.4, and you will get, that is a 12.80. That is the maximum height it can reach is a 12.80. The unit is not given in the question. And again, if we find out its a second derivative, then you will get d2h by dt square, that is a minus 10, which is the condition for again the maximum. You can understand this also. Otherwise you will say that, sir, how you differentiate first derivative and find the values and then again you are substituting. But if you see this equation, that is a dh upon dt, that is a 14 minus 10t, and if we differentiate again second derivative, it's a negative. Its value is a minus 10, which is less than 0. Therefore it's a condition for the maximum. Now we'll start the next. Again the same question will be repeated for you. A ball is thrown in the air its height at any time t is given by h is equals to 3 plus 14t minus 5t square. Find the maximum height. Find the maximum height it can reach. When h is equals to 3 plus 14t minus 5t square, differentiate this with respect to x. Derivative of 3, 0, 14 into 1 minus 10t. dh upon dt is equals to 14 minus 10t. When it reaches, if we differentiate again second derivative, then you will get minus 10. That is a condition for the maximum. When it reaches the highest point, its velocity is equals to 0. Therefore dh upon dt is equals to 0. And this is the main consideration for this problem. And also the condition for the maximum is also satisfied here. The value of the t is 1.4. H is equals to 3 plus 14t minus 5t square. Therefore, h is equals to 14 into 1.4 minus 5 into 1.4 bracket square. Therefore, h is equals to 3 plus 19.6 minus 1.96. Therefore, the value of h is equals to maximum height is equals to 12.80. Now the problem number 14. Now the next is find the largest size of a rectangle that can be inscribed in a semicircle of a radius 1 unit so that the two vertices lie on the diameter. Now, see this figure. In figure, a rectangle is inscribed in a semicircle. AB is equals to y, BD is equals to x. AB is equals to y and the BD is equals to x. This is the length of rectangle and this is the breadth. Now next is it's a radius. The radius of the circle, that is, find the largest size of a rectangle that can be inscribed in a semicircle of 1 unit radius. It means that we have given that BC is equals to 1, AC is equals to 1. Now this is BD is also, this is the breadth and this is the one we can find out by using the Pythagoras. That is, the value of CD is equals to in root of 1 minus x square. This is the CD and this is AC. Therefore, y is equals to in root of 1 minus x square plus in root of 1 minus x square. Therefore, y is equals to 2 times in root of 1 minus x square. Area of rectangle capital A is equals to x into y. The A is equals to 2 in root of 1 minus x square into x. And now we'll find out its value. This x is outside the radicand sign. When it comes here, it becomes a square. That is, A is equals to in root of x square in bracket 1 minus x square. Therefore, A is equals to 2 in under root of x square minus x raised to 4. Now differentiate this with respect to x. dA upon dx is equals to 2 into 1 upon 2 times in root of x square minus x raised to 4 into ddx of x square minus x raised to 4. Therefore, dA upon dx is equals to this 2 to get cancelled, 1 upon in root of x square minus x raised to 4 into 2x minus 4x cube. Therefore, dA upon dx is equals to, if we take the x as common, then 2x in bracket 1 minus 2x square upon x in root of 1 minus x square. This x and x get cancelled. Therefore, you will get dA upon dx is equals to 2 in bracket 1 minus 2x square upon in root of 1 minus x square. Now differentiate this with respect to x. d2a upon dx square is equals to 2 using the quotient rule. That is in root of, this is the u and v. That is v into, it means that is the in root of 1 minus x square into ddx of 1 minus 2x square minus in bracket 1 minus 2x square into ddx of root of 1 minus x square upon in root of 1 minus x square bracket square. And if we solve this is a root and derivative of 1 is 0. Minus 2x square, it becomes minus 4x. 1 minus 2x square into derivative of root of 1 minus x square, which is nothing but 1 upon 2 times in root of 1 minus x square into derivative of 1 minus x square, which is the minus 2x upon 1 minus x square. Square and radicand sign get cancelled. Therefore, which is the minus 4x in root of 1 minus x square plus x into in bracket 1 minus 2x square upon in root of 1 minus x square upon 1 minus x square. Now we will simplify these, that is 2 minus 4x in bracket 1 minus x square, this is simplification, plus x into in bracket 1 minus 2x square upon in root of 1 minus x square into in root of 1 minus x square. Now product of this is minus 4x plus 4x cube plus x minus 2x cube upon 1 minus x square raised to 3 by 2. Now simplify this, that is a 2 in bracket 2x cube minus 3x upon 1 minus x square bracket raised to 3 by 2. Therefore dA upon dx is equals to 0. That is a 2 in bracket 1 minus 2x square upon in root of 1 minus x square. Therefore, the first derivative is equals to 0 to find the value of x. And that's why 1 minus 2x square is equals to 0, x square is equals to 1 upon 2, and the value of x is equals to plus or minus 1 upon root 2. Therefore, x is equals to 1 upon root 2 as x is greater than 0. Therefore, now we'll find out its second derivative. That is a d2a upon, we have calculated it's a second derivative, and we'll substitute the value of x there. And after the calculations, this is the, that is a 2 into 1 upon root 2 bracket cube minus 3 into 1 upon root 2 in a square bracket 1 minus 1 upon root 2 bracket square raised to 3 by 2. And you simplify this. This is a 1 upon 2. 1 minus 1 upon 2, that is 1 upon 2 raised to 3 by 2. And this is a 1 upon root 2 minus 3 upon root 2. That is a 2 in bracket 1 upon root 2 minus 3 upon root 2. And 1 upon 2 into 1 upon root 2. That is a, if we simplify this, that is a 2 minus 2 upon root 2. And here is a 2 upon 2 root 2. If we simplify this, then you will get minus 4, which is a less than 0. Therefore, the area is a maximum when x is equals to 1 upon root 2. And now what is the value of the y? The y is equals to 2 in root of 1 minus x square. And again, if we simplify, that is the value of the y, that comes to 2 upon root 2, that is equals to root 2. Hence, a is a maximum when the length of rectangle y is equals to root 2 and the breadth of rectangle x is equals to 1 upon root 2. Now see this again. Find the largest size of a rectangle that can be inscribed in a semicircle of radius 1 unit, so that two vertices lie on its diameter. That is, here E and D are the two vertices of the rectangle which lies on the diameter. In figure, rectangle is inscribed in a semicircle. AB is equals to y and the BD is equals to x. If we join this, that is a BC. The radius is unit and the value of CD is in root of 1 minus x square using the Pythagoras, and again the value of this is 1 minus x square. Therefore, y is equals to EC plus CD, that is in root of 1 minus x square plus in root of 1 minus x square. That is y is equals to in 2 times in root of 1 minus x square. Therefore, the area of rectangle is equals to x into y. Therefore, a is equals to in root of 2 times in root of 1 minus x square into x, and that is nothing but a is equals to 2 in root of x square in bracket 1 minus x square. That is the a is equals to 2 in root of x square minus x raised to 4. Now differentiate this with respect to x. dA upon dx is equals to 2. 1 upon 2 times in root of x square minus x raised to 4 into derivative of x square minus x raised to 4. That is the dA upon dx is equals to 1 upon in root of x square minus x raised to 4 into 2x minus 4x cubed. Therefore, dA upon dx is equals to, we take the 2x as a common, then in bracket you will get 1 minus 2x square. X square as a common, that will become x in root of 1 minus x square. Now simplify this. That is a 2 in bracket 1 minus 2x square upon in root of 1 minus x square. This is the dA upon dx. Now we'll find out its second derivative, and by using the quotient rule. d2a by dx square is equals to 2 times in root of, this is v, that is in root of 1 minus x square into ddx of 1 minus 2x square minus in bracket 1 minus 2x square into ddx of in root of 1 minus x square upon v square, that is nothing but root of 1 minus x square bracket square. That is in root of 1 minus x square, derivative of 1 minus 2x square, which is a minus 4x, minus in bracket 1 minus 2x into dd derivative of root of 1 minus x square, that is a 2 in root of 1 minus x square. Derivative of 1 is 0 and in x square is at minus 2x. 1 minus x square that is minus 4x in root of 1 minus x square plus 2x in bracket 1 minus 2x square After simplifying, you will get x in bracket 1 minus 2x square upon in root of 1 minus x square upon 1 minus x square. Now again simplify this, that is a minus 4x into in bracket 1 minus x square plus x into 1 minus 2x square, and after simplification we will get this, that is a 2 in bracket 2x cube minus 3x upon 1 minus x square bracket raised to 3 by 2. Therefore, dA upon dx, now its a first derivative is equals to 0. That is a 2 in bracket that is 2 in bracket 1 minus 2x square equals to 0. 1 minus 2x square is equals to 0. X square is equals to 1 upon 2. X is equals to plus or minus 1 upon root 2. X is equals to x is positive. X is equals to 1 upon root 2. Now we will substitute the value. X is equals to 1 upon root 2. Therefore, d2a upon dx square is equals to 2 in bracket 2x cube minus 3x upon 1 minus x square bracket raised to 3 by 2. If we substitute the value, if we substitute it and after simplifying, this is simplification, that is 1 by root 2 minus 3 upon root 2 upon 1 by root 2 bracket cube, that is 1 upon 2 into 1 upon root 2, 1 upon root 2, 1 upon root 2, 1 upon 2 into 1 upon root 2. Now if we simplify this, that is a minus 2 upon root 2, which is minus 4, and it is a negative. Therefore, the area is a second area is negative at that value. Therefore, the area is a maximum when x is equals to 1 upon root 2. Y is equals to 2 in root of 1 minus x square. That is equals to 2 in root of 1 minus 1 upon root 2 bracket square. If we simplify this, that is a 2 into in root of 1 upon 2. That is a 2 upon root 2, and that is equals to root 2. Hence, A is a maximum These are the values of length and breadth. Now the next problem is these are the values of the length and the breadth of that rectangle. Now the problem number 15. An open cylindrical tank whose base is a circle is to be constructed of metal sheet so as to contain a volume of pi a cubic centimeter of water. Find the dimensions so that the sheet required is minimum. We want to construct the cylinder, okay, whose base is a circle to be the constructed of the metal sheet so as to contain the volume, that is a pi a cube, volume of the water. Find the dimensions so that the required sheet must be the minimum. Let r be the radius of the cylinder, h be the height of cylinder. Volume of cylinder is equals to V is equals to pi r square into h. Therefore, V is equals to pi a cube. We have given that the value of this V, which is the pi a cube. We are substituting here pi a cube. This pi get cancelled. Now here h is equals to a cube upon r square. Now S is equals to the curved surface area plus area of base. Now what is the curved surface area? The curved surface area is 2 pi RH plus pi r square. Therefore 2 pi r and substitute the value of h, that is a cube upon r square plus pi r square. S is equals to 2 pi a cube upon r. This r get cancelled. And here is a pi r square. Now differentiate this with respect to r. Therefore, ds upon dr is equals to the derivative of 1 upon r. We know the derivative of 1 upon x is minus 1 upon x square. In the same manner, we have the derivative of 1 upon x is r is a minus 1 upon r square. What about the next? Derivative of pi r square, which is a 2 pi r. This is the ds upon dr, that is a minus 2 pi a cube upon r square plus 2 pi r. Now differentiate this with respect to again r. Then you will get that is a 2 pi a cube, the derivative of 1 upon r cube, that is a minus 2 into 1 upon r cube, and this is the 2 pi and the derivative of r is a 1. Therefore d2s upon dr square is equals to plus 4 pi a cube upon r cube plus 2 pi. This is the second derivative. And now we'll equate the first derivative equals to 0. Therefore, the first derivative equals to 0. Now the ds upon dr is equals to 0. Therefore, if we substitute that is equals to 0, that is a minus 2 pi a cube upon r square plus 2 pi r. The value is 0. And after the simplification, you will get a multiply on both sides by r square. Then you will get minus 2 pi a cube plus 2 pi r cube, that is equals to 0. R cube is equals to a cube. R is equals to a. Now the d2s upon dr square is equals to 4 pi a cube upon r cube plus 2 pi, which is a positive for r is equals to a. Therefore d2s upon dr square means this surface area is the minimum for this condition. Therefore, by the second derivative test, s is the minimum when r is equals to a. Therefore, h is equals to a cube upon r square, that is equals to a. Hence, the quantity of the metal sheet is minimum when r is equals to a, that is the radius is equals to height. Now, again, we'll see here. An open cylindrical tank whose base is a circle is to be constructed of metal sheet so as to contain a volume of pi a cube. Pi a cube cubic centimeter of water. Find the dimensions so that sheet required is minimum. Let R be the radius of cylinder. H be the height of cylinder. Volume of cylinder is equals to pi r square into H. And we have given that V is equals to pi a cube. Now we'll equate this here. Pi r square into H is equals to pi a cube. Pi get cancelled. H is equals to a cube upon r square. Now S is equals to curved surface area plus area of the base. Because the cylinder is open, we will add here curved surface area plus area of the base. 2 pi rh plus pi r square. That is a 2 pi r into the value of h, a cube upon r square plus pi r square. 2 pi a cube upon r plus pi r square. Now differentiate with respect to r. ds upon dr is equals to 2 pi a cube. The derivative of 1 upon r is a minus 1 upon r square plus 2 pi r. Therefore, ds upon dr is equals to 2 pi a cube minus 2 pi a cube upon r square plus 2 pi r. Now differentiate this with respect to again r. d2s upon dr square is equals to minus 2 pi a cube minus 2 into 1 upon r cube plus 2 pi into derivative of r is 1. And if we again simplify, that is a 4 pi a cube upon r cube plus 2 pi. This is the d2s upon dr square. It's clear that this total value is positive. Second derivative is a positive and it is nothing but the condition for the minimum. That is, its surface area will be minimum. That is, a ds upon dr is equals to 2 pi a cube upon r square plus 2 pi r. Therefore, ds upon dr is equals to 0. 2 pi a cube a square upon r square plus 2 pi r is equals to 0. That is, a 2 pi r cube is equals to 0. R cube is equals to a cube. R is equals to a. Now again d2s by dr square d2s upon dr square, that is a 4 pi a cube upon r cube plus 2 pi, which is the positive, for r is equals to a d2s upon dr square by the second derivative test. S is the minimum when r is equals to a. That h is equals to a cube upon r square. Therefore, h is equals to a. Hence the quantity of metal is minimum when r is equals to a. That is, radius is equals to height. Now the next is, I'll see the problem number 16. The perimeter of a triangle is 10 centimeter. If one of the side is 4 centimeter, what are the other two sides of the triangle for its maximum area? We have given that here the perimeter, that is equals to 10 centimeter. It's a one of side. If we consider this is the triangle ABC, AC is equals to 4 centimeter. 10 minus 4, that is equals to 6. And if we consider that is a one side, BC is equals to X. Then what about the AB is a 6 minus X. BC is equals to X, AB is equals to 6 minus X. AC is equals to 4 centimeter. What about its semi-perimeter? Semi-perimeter is equals to 10 upon 2, that is equals to 5. Area of rectangle is equals to in root of S into S minus A into S minus B into S minus C. If we substitute the values, that is the X, A is equals to X, B is equals to 4. And what about the value of C? This C is equals to 6 minus X. Therefore, that is in root of 5 in bracket 5 minus X, 5 minus 4, 5 minus 6 and plus X. That is A is equals to in root of 5 into 5 minus X into 1 into X minus 1. A is equals to, that is a 25 minus 5X into X minus 1. Therefore, A is equals to minus 25 plus 5X plus 25X minus 5X square. Therefore, A is equals to in root of 30X minus 25 minus 5X square. Now differentiate this with respect to X. dA upon dx is equals to, derivative of root X is 1 upon 2 times root X. 1 upon 2 times root X. In the same manner, here is a 1 upon 2 times in root of 30X minus 25 minus 5X square into derivative of ddx of 30X minus 25 minus 5X square. That is, we have here 1 upon 2 times in root of 30X minus 25 minus 5X square. That is, this is the 30 minus 10X, and again we will simplify here. We'll take 2 as a common. Then in bracket you will get 15 minus 5X upon 2 in root of 30 minus 25 minus 5X square. Again we will take the 5 as common. Then again simplifying, you will get dA upon dx is equals to root of 5 in bracket 3 minus x. And again find out the second derivative. d2a upon dx square is equals to root of 5. And this is the simplification that you will get. U upon v. Now this is the v, derivative of u into derivative of v upon v square. Now it's a square, that is a minus x minus 5 in bracket x minus 5 into x minus 1. And after simplification, finding the derivative of this, that is a 3 minus x is minus 1. This is the again the derivative. Now here is the second derivative, that is a d2. Again I am repeating here, d2a upon dx square, that is equals to in root of 5 in bracket 6x minus x square minus 5 into ddx of 3 minus x, minus in bracket 3 minus x into ddx of in root of 5 in bracket 6x minus x square minus 5, and the square of this quantity. If we differentiate this again, you will get, that is the 3 minus x, and derivative of this is a 5 in bracket 6 minus 2x upon in root of 2 in root of 5 in bracket 6x minus x square minus 5 upon the square of this quantity. And again the simplification, this is a tough simplification. Now this quantity will be multiplied here, and that's why you will get, that is a minus 5 in root of 6x minus x square minus 5 minus 5 in bracket x square minus 6x plus x square. And this is the power is 1 upon 2, and this is the 1, and it makes 3 by 2. Therefore there is a tough calculations is here. How you can understand, it depends on you. That is a minus 30x. Again if you simplify this, then you will get minus 30x plus 5x square plus 25u minus 45u, and this is the plus and again the minus, and upon the 5 in bracket 6x minus x square minus 5 raised to 3 by 2. Therefore d2a upon dx square is equals to minus 20 upon in bracket 5 in bracket 6x minus x square minus 5 bracket raised to 3 by 2. And this second derivative, that is at x is equals to 3, because the first here we will find out the value of this first derivative, that is equals to 0, and the value of x that comes is equals to 3. And if we substitute this value, then we get here the negative, and which is less than 0, and it is a condition for the maximum. Area is a maximum at x is equals to 3. The sides of the triangles are, b is equals to 4, a is equals to 6 minus x, that is a 6 minus 3, that is equals to 3. Therefore the sides are 4, 3 and 3. These are the required sides, remaining sides. One side is given 4 and the other two sides are 3 and 3. And again I am repeating here, these are the remaining two sides of the triangle, that is a 3 and 3. And in this way we have completed the fourth part of this exercise, because this exercise is big one. All the theoretical problems are there, therefore I am making these videos of the 1 hour only. And now we'll see in the last video of this exercise, that is exercise 2.4. In the next video the remaining problems will be there. Now we'll see in the next video. Till then, goodbye.